Welcome back to Daily LeetCode. It's day 136. I was reading some funny comments. We have a comment from Ice Cream Man 1337. It says, "My man, I don't think the Elon in your Discord is the real one. I promise you, he is the real one." So yeah, we've been in the Discord. We've been talking about the Twitter acquisition and stuff like that. So you're gonna want to join the Discord to hear more about this. We have a comment from Resurgam. Can you hack NSA pilots? We have some people working on this already. The data will be available for a specific amount of leak coins. Email us for more information. We have a comment from Kashyap. Man, can I join you on your routine? Please do. Learning can be fun. So this could be the wave. So we have Crisis Young King. It's good to see you on your grind still. I'm actually just starting to consider if I should learn to code. Yo, for the real ones that know Crisis, the real ones know Crisis. Real feels. This is a real feel strong man. So yeah, feel strong. Hey, I'm here, man. If there's a way I can help, I would love to. I might have to stop by Discord. Not sure if it's the same one as the old Twitch one. Only the real ones know about the old Twitch one. I sincerely wish you all. Hey, most definitely. All love, man. Miss you, brother. Feels strong, man. Crazy how times pass. Time pass, seasons change, but only death and taxes are certain. We have Aurelius. Haven't even watched yet, but the title is enough for me. Keep pushing, my guy. Oh, I thought the title is enough for me meant you weren't going to watch. I'm not gonna lie, the clickbait has gotten out of hand. I've been using many ellipses on the videos and very ambiguously clickable video titles. So maybe that's flames. Maybe I should stop it and get some help. But we shall see. But keep pushing. Hey, you too. Love your icon. Okay, we have a comment from more dots. Wait, how do you remove AABAB in only 2 steps? Edit. Oh, never mind. Palindrome substrings don't have to be contiguous. So every string is a combination of a non-contiguous AAA string and a yes, BBB string. If you got a big jumble and remove all the A's, you'll be left with just B's. 2 steps, unless it's yes. This is it. This is literally it. Nice. Yeah, that's literally it. It took me like 30 minutes to figure that out. So it is incredible that you were able to do that. So we have the LeetCode here once again. We're going to be doing a shorter session today, just because we are strapped for time. Tomorrow we'll do the usual 1 hour, but we're gonna do a shorter session today. And yeah, the goal there. So yes, so we have time. We're gonna do a short session. I said the lowest amount of time I would ever do is 15 minutes, but today we're gonna be doing a shorter session at 25 minutes, just because life be like that sometimes. But sometimes you have to walk or even crawl so you can run. So a necessary evil, maybe hopefully for a necessary reward. But the Discord bot is complete, and there'll be more information about it tomorrow. I don't think it's going to be that big of a hit, but maybe people will think it's cool. Maybe some people will use it. I'm just kind of trying to encourage more communication in the Discord, so we shall see. And we're going to jump into it. So we have 25 minutes to get started. So we have count binary substrings. This is a function. Given a binary string S, return the number of binary string S can return the number of non-empty substrings. Non-empty substrings that have the same number of zeros and ones, and all the zeros and all the ones in these substrings are grouped consecutively. Okay, so we have binary string S, trying to visualize it. Return the number of non-empty substrings. Non-empty substrings that have the same number of zeros and ones, and all the zeros and ones in these substrings are grouped consecutively. What does that mean? So we have the same numbers of zeros and ones. So we'd have 0, 0. There are 6 substrings that have equal number of consecutive ones and zeros. Have the same number of, and all the zeros and ones in these substrings are grouped consecutively. So you have 0, 0, 1, 1. We have 0, 1, 1, 1, 0, 0, 1, 0, 0, 0, 0, 1. Notice that some of these substrings repeat and are counted the number of times they occur. That's true. It was 0, 1, and 0, 1. Not a valid substring because all the zeros and the ones are not grouped together. Basically, okay, so I see what they're saying. When they say consecutive, they mean like a categorical sequence. So you have to return the number of non-empty substrings that have the same number of zeros and ones. Given a binary string S, return the number of non-empty substrings that have the same number of zeros and ones. And all the zeros and all the ones in these substrings. I think the phrasing consecutively here is confusing. So you have 0, 0, 1, 1 maps correctly. Then we have 0, 1 within that same string. And then we have 1, 1, 0, 0. Then we have 1, 0, 0, 0, 1, 1, and 0, 1. I think we could do this in n squared time. So let's see if we can get this right. I think we'd have 1, 0, 0, 1, 1, 0, and 0, 1. 1, 0, 0, 1, 1, 0. So when I say n squared, the reason I think we could do it in n squared is because given a string that looks like this, what we could do is use the sliding window pattern. So we could have something like, for example, given the string again, a window which starts at 0, right? And we'll try for each index. For each index, we'll pretty much try and create the longest consecutive group string. So you'd have 0. So we start at 0. We'd say, okay, we have 0. We found another 0. Okay. Then we found a 1. We're still not consecutive yet. Then we found another 1. It's like, okay, well, that's one version, one group, right? But then we try to find, once we find the 0, we'd have to stop because they wouldn't be consecutive anymore. So I think we have a couple things here that is a little nutty. First thing being, we're going to need a data structure, or we're going to need a way to tell for a given iteration. For a given iteration, we need a way to tell the mappings. For a given iteration, we need a way to tell the mapping. So if we have 0, we have a couple of, I'm trying to think of it in like a modes perspective. We start at 0. then we'd have another 0, right? That's fine, but we want to, now we find a 1, we want to switch to looking for 1s. So what if we had a Boolean for finding both 0s and 1s? So we found a 0, and we could say found a 1. And then 2, 0, 1, 1. So I don't think that's gonna work. Given iteration, we need a way to tell mappings. This version feels like it'd be a systems-driven approach. I'm trying to create a system that pretty much finds these groups of strings. Maybe there's a simpler answer. I don't see a solution that's not n squared. You could start with a string, start with a character and try to create the longest consecutive string you can. For given iteration, you need a way to tell mapping. I'm having a bit of trouble focusing. This does feel like one of those problems where the solution is hidden in the math and I just need to look through. Whereas I think typically with the medium, you just have to find the overarching approach and the problem kind of opens up. We definitely want to iterate for each character. For each character, find largest. For each car, we want to expand window until we're non-consecutive. Maybe we could do this by keeping a buffer. We could keep an array. This array would store the number of pretty much the last 2 types we were looking through. In this case, would just be 0 and 1. We don't want to use a set because that's going to take away the ordering. If we start with a 0, I think we got it. If we start with a 0, right, then we'll add 0 to the buffer. This buffer, it's not really a buffer. We're just going to say it's a grouping or a scene. Right, we've already seen 0. So it's okay for us to add 0s because we're looking for 0s. As soon as we find a 1, we know that we want to switch to 1 mode. We're looking for 1s, we can add it to scene. Now, if the next character ever equals the first thing we saw, we'll know we're non-consecutive anymore. So now we know we have a way for each character to expand the window until it's non-consecutive. And then for each iteration, what we can do to tell whether or not we have the same now we have a way to tell if you expand the window until it's not consecutive. Now we just need a way to now we have a way to expand the window until it's non-consecutive. Now we just need a way to count the groupings. So we can assume that the window, well, if it expands until it's non-consecutive, like we want to expand the window till non-consecutive and expand the window until it's non-consecutive The problem is if we were to expand the window until it was non-consecutive, we'd have an issue because when you start with 0, equals the first one. I think we could if the current character is equal to the first character seen. It's going to be in a red. It looks like this. If it equals 0, if it equals the last character in scene, then we'd be good. We'd be good. So we'd add it to. We would add it to our window, so we'd have 0. Then we'd add 0 again because it's equal to where we're at. I think this could work. We're trying to map it first. We can expand the window until it's non-consecutive. That means we can't actually get the window to a portion where we have a valid string or a valid window. So we don't want to expand the window until it's non-consecutive only. I want to expand the window until it's non-consecutive. And we've seen both cars. We've seen both cars and we know it's okay for us to stop as soon as it's non-consecutive. So it's non-consecutive and we've seen both cars. Then we'd be good. The problem is we'd go 0, 0, and then we'd add 1. It technically would be non-consecutive. No, it wouldn't actually, because we'd still add the string. Still add the string because I'm envisioning it as a triple if case. If being, if the current character matches the last character in scene. So when we're first finding 0, it's going to be 0, going to add it. Then we're going to find 1, which is going to be separate. It's going to be different. So we're going to now say scene is equal to the character we just saw. Now while the character matches the first character, we want to keep adding to see how big we can make the consecutive window. And the else case is going to be, the else case would be if the current character is equal to the first thing we saw, then we know that we should probably stop. Would that let us get to 0, 0, 1, 1, 0, 0. I think it'd be just two cases. If we've seen at least two characters, if we've seen at least two characters, if we've seen at least two unique characters, if we've seen at least 0 and 1, and the current character matches the first character we saw, then we want to stop. Otherwise, we want to add the character. If we add the character to the window, then we'd have the window currently, and then we'd need some method then we can just keep track of another variable like 1s and 0s. And if 1s and 0s are the same and greater than 1, greater than 0, we want to add 1 to the number. So I think it might just be mapped out enough. We're going to have CT equal to 0. We're going to return CT. We'll iterate over the string. All I is less than s dot length. I plus plus, and then we're going to have a scene array, which is just going to be an array of strings, basically. They're going to have 1s, starts at 0, and 0s, it starts at 0. They'll get set to 0 at the start, and then for each character in S, we're going to try and expand the window as much as we can. Say let m equals I, m is less than s dot length, m plus plus, so to start, we'll just add it into scene. We'll just say scene is going to be equal to s sub I. And then when we start, the loop will actually look past it. So I have two cases, right? If scene.length equals 2, this is when we'll stop expanding the window. If we've seen at least both, and s sub m equals scene sub 0, which would be different, then we just want to stop, basically. We want to stop expanding the window and just break out. Else, it means we can just add it to the window. Which basically means if s sub m equals 0, we'll do 0s plus equal 1. Else, right, it must be 1s plus equal 1. So we'll do the else, and then we just need to check that. Oh, right, I forgot. If zeros is greater than 0 and ones is greater than 0 and zeros equal ones, then CT plus equal 1. Dang, I really thought we were going to get it on the first try. Wait, I think I see what the problem is. We need to increment the zeros and the ones. We also need to add it to scene. If S sub m does not equal scene sub 0, I'm going to say scene dot push S sub m. No, wait. If S sub m does not equal scene sub 0. No, that's scene sub 1. Yeah, something's slightly off. I think we just run this through this real quick. We'll figure it out. So ones equals zeros. Ones equals 0, zeros equals 0. Scene is equal to an array of S sub I, which is equal to 0. Now we're going to start at this next 0 here. If scene dot length equals 2, it doesn't. So we're going to say else. Okay, if S sub m does not equal S sub m, scene dot length does not equal 2. Since it doesn't equal 2, we're going to say, okay, if S sub m, which is 0, does not equal scene sub 1, which does not exist. So if S sub m does not equal the most recently seen character, then do scene dot push S sub m. Most recently seen character would be 0. Most recently seen character would be 0. So we don't want to do, because it would equal. So we say S sub m equals 0. Then we're going to add 1 to 0. But if we did scene, so we'd have zeros. Oh, I think the other issue. So we say we need to start S sub I equals 0. If it equals 1, then we'll start ones at 1. Otherwise, we'll start it at 0. And we'll do the same thing here. So, so we should have 2 zeros now. And this is not equal 2, so we're not even going to go there. Go to the next iteration, we have 1. Okay, scene.length still equals 1. So we're going to go to else if S sub m, which is now 1, is not equal to the last character we saw. It doesn't. Last character we saw was 0. So then we're going to do scene.push S sub m. That means now scene is going to have 0 and 1. S sub m is not equal to 0, so it's 1 plus equal 1. scene dot length is 2, but zeros is 2, and ones is 1, and they're not the same. Either this is working or this is the worst. Yeah, okay, so we got it to work, but n squared is unacceptable. N squared is unacceptable. I think we could make this linear time if we did the window over the whole thing. The next index we would start at would actually be the length of the index over 2, because that's where the next one would restart. Then we could add these. Those that work for this. 1, 0. Next one we start would be 0, 1. So let's try this. So then in here, I think we can just, we'll set this equal to I. We'll start at I equals 1, change this to I, and we'll change all instances of. And then instead of a for loop, we're gonna let idx equal to 0, idx equal to 1. We'll say, well, idx is less than s dot length. And instead of idx, we just change to I, so we have to rename less variables. We pretty much want to expand the window as much as we can, so whenever we push this in here, pretty much we're always going to be adding at least one character. Now, if we find that we're going to stop, what we'd like to do instead is do CT plus equal. We don't have to do that anymore. Do CT plus equal window divided by 2. And then we'll do I is equal to window divided by 2. So we find the first one, so it'd be like 0, 0, 1, 1, 1. Right? Our I is equal to 0. We'd like to do I is equal, I plus equal window over 2, basically. So 0, 1, 2. And then we can take away a break. Oh, I forgot to do I plus equals 1. Well, actually, we'd have a start. No, I just realized we could have kept our original outer loop and just turned the outer one into a while loop. We're just going to stop there. Use old solution, turn outer loop to while loop, and this would have worked perfectly, actually. I think this would have worked perfectly if we had just done that. But maybe the worst case would still be, yeah, even then the worst case would still be yeah, we'll have to come back to this tomorrow when I can think a little more clearly.